How many do we have? It's only 7 people in there.
Hello, everyone. We will start on time as always, because at the beginning is always my short introduction. So something which is not such attractive than other parts of our meeting. But let me say a few words in Polish for those who need translation. Ci, którzy z Państwa, którzy chcą translacji, jest oczywiście jak najbardziej to możliwe. Trzeba tylko nacisnąć taki magiczny przycisk Interpretation i tam można się przełączyć. Tyle, że ważna uwaga, że to jest przełączenie na język portugalski. Z jakich powodów to jest, trudno mi powiedzieć. Być może Zoom po prostu nie ma takiej ikonki, więc ci, którzy z Państwa chcą, no to właśnie używając tego przycisku mogą się przełączyć, mogą się oczywiście też potem z powrotem przełączyć, więc taki mamy komfort. No i jeszcze taka informacja, że no wszelkie problemy tego rodzaju techniczne to proszę informować czat i my sobie z tym jakoś poradzimy. Okay, so now I would like to move back to English. Last year in our center, we conducted a national-wide survey on the perception of social robots, and we see that people are very curious about them, about social robots, especially humanoid robots, but also at the same time, they are very afraid of them. So it's, in my opinion, it's worthy learning about intelligent machines, and it's worthy to find out more about intelligent machines. So that's why this is the idea behind our today's event. And also a short information about our project is a series of meetings focused on new technologies. It's a combination of the world of science and business, but also the humanities and technology, and also connecting our Polish, let's say, reality with foreign countries, foreign scientific and business reality. Our project is co-financed by the Polish Ministry of Science and Higher Education. As you see, we are still suffering from the pandemic, so that is why we changed the formula of our meeting. At the beginning, we had meetings in real time. Now we move to the formula of webinars. We have, let me also present and share screen, because I would like to present our partners. We have wonderful partners. So I would like to thank you for your support. You see on the screen Sztuczna Inteligencja, Ośrodek Przetwarzania Informacji, Państwowy Instytut Badawczy, Zrobotyzowany.pl, ITWIS i panel Ariadna. Regarding organization of our meetings, because the idea is still the same, our meetings always consist of 2 lectures and a panel that follows them. There is also a chat box. You can comment in real time, ask questions, but if someone wants to ask questions verbally, it's also possible, but you have to just raise your virtual, let's say, hand. But every time, as I said before, you can put on this box, and we can read this questions. If the panelists or speakers want to answer, of course they can do it. So I don't want to extend too much this introduction because I would like to give our guest more time. Today, our keynote speakers will be Professor Agnieszka Wykowska and Professor Christoph Bartneck. The first speaker will be Professor Agnieszka Wykowska. On the screen, you have the whole profile, her profile, but let me very briefly read information about Agnieszka Wykowska. Agnieszka Wykowska leads the unit Social Cognition in Human-Robot Interaction at the Italian Institute of Technology, but also works at the Luleå University of Technology, is in Sweden, I guess. At the University of Manchester. She graduated from Ludwig Maximilian University in 2016. She was awarded the ERC starting grant in instance. She's an editor-in-chief of International Journal of Social Robotics and an associate editor of Frontiers in Psychology. She's a board member of the European Society for Cognitive and Affective Neuroscience. In her research, she combines cognitive neuroscience methods with human-robot interaction in order to understand the human brain mechanism interaction with natural and artificial agents. So I guess we will listen about Agnieszka's studies and I guess ICAP project, because I know this wonderful, amazing project, and I'm very curious about this presentation. So Agnieszka, we are asking you for the presentation. Our virtual floor, our Zoom, our screen is yours.
Thank you very much. Thank you, Konrad, for the super nice introduction and for inviting me here. It's a great pleasure and honor to be here and speak. As you said, too bad it has to be virtual, but that's what 2020 is all about. All right, I'll try to share my screen now, and let's hope it works. Okay. And I hope you see it in the full screen mode, yes?
Yes, it's visible.
Okay, good. So I would like to talk to you tonight about the work we're doing in our lab related to social cognition in human-robot interaction. As Konrad mentioned, we work with the ICAP robot, the robot that has been developed in our institute. I'm not a roboticist, so I wasn't the person who designed or developed the robot, but I work on the human-robot interaction side. So yeah, what is the aim of all of us basically working in social robotics or human-robot interaction fields? We would like to have assistive social robots helping us out in daily activities, perhaps assisting us during shopping activities, as you see here. I don't know if you can see my cursor here. Ultimately, we would like to have robots assisting in elderly care, child care, and that's our dream. We would like to be there one day, but unfortunately, in reality, we are very, very far away from that. So in reality, our robots behave and look pretty much like this. So you see they're very, very clumsy. They can't really do their tasks properly yet. There is really an enormous amount of effort that still needs to be put into robotics to make them up for the task of being our assistants. So what do we need to do? Well, from the robotics and AI side, there's, as I say, an enormous effort that needs to be put still into endowing robots with intelligence and eventually with autonomy, and actually being able to navigate our environment in an efficient and intelligent way. But I'm not going to talk about robotics because, as I mentioned at the very beginning, my background is not robotics. My background is in cognitive neuroscience, and so I'll be talking about that part of the human-robot interaction side. So the human side, and also from the human perspective, there's really a lot that needs to be done. We need to understand the mechanisms that the human brains employ during human-robot interaction. We need to ask the question, what are those mechanisms, how they are different or similar to social mechanisms when we interact with other humans, and what can we do better to make an interaction more intuitive. All right, so in order to address these questions from psychology and cognitive neuroscience perspective, we use methods of cognitive neuroscience. We use paradigms that we adapt from psychology, and we make those paradigms more interactive with, as you see here, a participant is interacting with the iCap robot, and at the same time she's wearing an EEG system. Here what you can see is the mobile eye tracker. So we're measuring her brain neural responses, but also her behavior while she's interacting with the iCap robot. So we're trying to bring psychology paradigms into more interactive scenarios, but at the same time keep the experimental control of psychological paradigms. So that's about methods. Now the key questions that we're asking in our lab are the following. And I will focus on those two, and my presentation is structured along those two questions. Do humans adopt intentional stance towards humanoid robots? That's the first question. I'll explain in a moment what I mean by intentional stance. And the second question is whether humans attune socially with robots. So what is intentional stance? That's a concept that is a philosophical concept, first introduced by Daniel Dennett. And the idea here is that when we observe and interact with other humans, we typically try to predict and explain their behaviors with reference to mental states. So when you see another person looking towards a glass of water and reaching out to that glass of water, you explain their behavior that they are trying to grasp that glass of water because they want to drink, because they believe that water will ease their thirst. Wanting and believing is a mental state, right? So intentional stance is a stance that we take when we explain and predict behaviors with reference to mental states. This is something that we do very automatically with other humans. On the other hand, when we observe machines, artifacts, we wouldn't explain their behavior with mental states, with reference to mental states, right? So if you see a coffee machine, or if you interact with a coffee machine and your coffee machine is generating coffee for you, at some point it stops, you don't explain that behavior as that the coffee machine wanted to stop, was trying to be mean to you and was trying to deceive you. You explain that behavior in such a way that you probably refer to how it was designed to behave, right? So when I push the brakes of my car, the car stops. I know it stopped not because it had such a whim, but because I wanted it, because it was designed in such a way. All right, so you can see that already here that humanoid robots might actually be an interesting artifact, because on the one hand, they are machines, so they should be, their behavior should be explained with reference to their machinery and the function, so with adopting the design stance. On the other hand, because they look like humans and maybe sometimes behave like humans, we might be tempted, or maybe even automatically, we might adopt the intentional stance towards them. It's very easy for us humans to adopt intentional stance, not only to humans, but also to other entities. So the big question here is whether people do adopt intentional stance towards robots and under what condition that happens. Okay, but first, before we can ask a question under what conditions this adopting intentional stance happens, we need to have the means to actually measure whether people adopt the intentional stance. And that's quite a challenging task, because we're talking about a philosophical concept on the one hand, the intentional stance. On the other hand, we want to operationalize it somehow in such a way that we would be able to empirically measure adopting intentional stance. So in our team, we have developed a tool that we think measures the adopting the intentional stance. And I'll first just very quickly introduce you to that tool, and then I'll present you with some interesting data related to this tool. So the idea here is that we were trying to be as close as possible to the original idea of Daniel Dennett, and we stick to the concept that adopting intentional stance is predicting or explaining behavior with reference to mental states. So what you see here is 2 items of a test that consists of 34 items of that sort. So one, let's say, row is 1 item, and each item is a set of 3 pictures like these. So you see that there's a story here, and you might want to understand what is happening in this story. And what we do is we present participants with these sort of pictures, and underneath those pictures, well, with different versions of the test, it's either underneath or not necessarily underneath, but with those pictures, you see 2 descriptions of what ICAP is doing. And one description of ICAP is mentalistic. So ICAP was trying to cheat by looking into opponent's cards, right? Or ICAP was unbalanced for a moment. The other description is quite mechanistic. And so the idea here is that participants should choose, they are asked to move the slider here to the description that they think fits best to the scenarios that they've observed. And now if you code, so you see that in the slider, you can basically think of it as a scale from 0 to 100. And if you code mechanistic responses as 0, extreme mechanistic as 0, and extreme intentional as 100, what we have observed that on average, people score around 43, meaning that they are more towards mechanistic side, so they're not completely in the middle. And that is kind of obvious because, of course, we present them with a robot. But on the other hand, they're not completely 0. So they do have some tendency to go towards the intentional descriptions. And interestingly, what we have observed is that participants actually differ quite a lot in the scores and in how likely they are to adopt the intentional stance. And that was something quite fascinating for us to already observe that. Then we were trying now to understand what is behind those individual differences. But before we started digging into that, we ran one modification of this test. And that modification was with EEG. So we asked participants to answer these sort of questions and, or let's say, choose those descriptions. And while they were doing that, we were measuring their EEG signal. And so very interestingly, or maybe first I'll just tell you quickly about the design. We had to modify the design a little bit for EEG. So the reason why we needed to do that is that we didn't want people to read on the screen so that there wouldn't be artifacts in their eye movements. And so we presented participants with descriptions through headsets and auditorily. So there was a bit of modification of that paradigm. But the interesting part that we were looking at was whether we can predict from neural activity before participants make the response, whether they would have a tendency to go towards the intentional or mechanistic descriptions. So we looked at, during the task, we looked at the EEG segment here just before they released a key in order to make a response. And actually, we were able to classify participants, so not on by trial basis, but we were able to see which, who of our participants would be more likely to choose an intentional answer and who would be more likely to choose mechanistic answer. So this comparison is between subjects. What is also very interesting that we see in neural activity in the gamma range, that even before participants respond, we can already see differences in the neural activity. Even more fascinating to us was to observe that we can classify participants to either intentional or mechanistic participants even before they did the task at all, so during resting state. That's a procedure that is typically done when we are interested in kind of like resting state activity of the brain. So participants come to the lab, they are asked just to relax while they already have the EEG cap on, and we measure their EEG activity. They don't know what their task is going to be. They haven't seen the robot yet. They haven't seen the task. They haven't been instructed about anything. And what we measure is that kind of resting state activity. From that, we were able to classify people into those who were more likely later on to adopt intentional stance towards robots as compared to those who are more likely to adopt the design stance. And that's quite fascinating because that shows that there are certain markers in EEG activity that are predictive of the attitude that people have towards robots. Okay, so to conclude this part, what we have observed is that people differ in their likelihood of adopting intentional stance towards robots. And these differences can be detected at the already neural level at rest. Now let me move to the other question, the question of social attunement. So I'll also guide you through the concept and the question of whether and how and under what conditions people attune with humanoid robots. So social attunement for me is an umbrella concept under which we subsume all sorts of mechanisms of that our human brain employs during interactions with other humans. So here in this short video, you'll see like illustration of selected sample of these kind of mechanisms. And they are very often employed in interactions in an implicit way. So we're not necessarily aware that our brain does that, but we know from literature and from empirical studies that that's what happens. So the mechanisms that we're interested in are mechanisms such as mutual gaze, which is extremely important for establishing interaction, joint attention, gestures that we use to communicate intentions, then understanding intentions and some sort of social signals that communicate that we've understood those intentions, then joint action, cooperation, and anything that is involved in that. And then emotional synchronization that sort of is also a signal that we succeeded in our joint action. So this is just a sample, a selected set of mechanisms that our brains use all the time, every day when we interact with others. And all those mechanisms I subsume under this one umbrella concept of social attunement. Now the question is whether social attunement is evoked also in interaction with humanoid robots. So in order to, I'll first talk about joint attention, and in order to investigate that, again, as I was saying at the beginning of my talk, what needs to be done is that we need to take, or let's say, adapt paradigms from cognitive psychology to address these particular mechanisms. So how is joint attention operationalized in the lab? Maybe first, before I get there, let me tell you very quickly what I mean for those of you who are not necessarily in the cognitive psychology field. Joint attention is a mechanism that allows two people to, or more, to attend to the same event in the environment, either object or event in the environment. And that is usually achieved by social gestures, such as pointing or gazing at an event. So if we were in a, let's say, more less virtual environment, then I could point to you in a certain direction. And once I point, you would probably automatically look there. This is what we do with other people, right? We look at where they're pointing, where they're gazing, because they're signaling something to us, something that is important in the environment. And when we do that, we engage in joint attention. And this has been operationalized in the lab in the so-called Posner cueing or gaze cueing paradigm, where we present typically participants with a directional cue, like you see here, that's an arrow that should direct our participants' attention to one of the sides. And later on, we present a target letter there that participants are asked to discriminate, either a T or an F. And once we have allocated or oriented their attention to that location in space, then we assume that participants should be faster as compared to a situation when, as compared to a situation, then I don't know why this is moving back and forth, sorry. That's my computer doing this. As compared to a situation when they have to move between cued location and the location where actually target has appeared. So this kind of experiment can then be also translated into a more social situation where instead of the arrows, you see gaze. I really don't know why my computer is jumping back and forth between the screens, but hopefully this will be now stable. All right, so instead of arrows, you can also present eye-like stimuli and see whether participants indeed engage in joint attention. So when they show the differential effect between cued and uncued location, that means that they followed the gaze of, in this case, a schematic phase. So here we implemented this kind of paradigm in a human-robot interaction, and our ICAP robot was directing participants' attention to one of the screens. And on the screen, participants saw a letter, and that letter could be either validly or invalidly cued by the ICAP robot. All right, so this is an example of a paradigm where we took something from cognitive psychology and implemented this in an interactive scenario. So this is how it looks. Excuse me, I will just add one more thing. Very importantly for this experiment, what we have manipulated in addition to the gaze validity, we manipulated whether the robot would engage in mutual gaze with participants or it would avoid the gaze. And our question of interest actually was whether the gaze cueing effect would be modulated by mutual gaze with the robot. So let me do this from the beginning now. So first, ICAP engages in eye contact in this condition, then it cues our participants' attention to one of the screens. Target is presented there in the valid case, or the target is presented in the opposite screen in the invalid case, right? And this is one condition. In the other condition, there's no eye contact at first. And again, validly or invalidly cued targets. So the idea is that if participants need to refocus their attention because they followed ICAP's gaze, if they need to refocus their attention to the opposite side, that should slow them down in responding to the target. And we wanted to see whether that effect would be modulated by mutual gaze with the robot. And in fact, with our first experiment, this is what we observed, that eye contact did modulate the gaze queuing effect. So when you see a difference here in reaction times in the invalid as compared to the valid condition, that means that participants engaged in joint attention with the robot. And they did so in the eye contact condition, but not in the no eye contact condition. This is just, as I say, first experiment, then we ran a follow-up, many follow-ups of these experiments. The story is a little bit more complicated than that, but I'll just leave you with this for a moment. And I wanted to tell you that across all the experiments that we've run, even though the gaze queuing effects and the modulation by the mutual gaze sometimes differed and was dependent on various other factors, what we observed is that participants in subjective ratings of how they felt engaged with the robot, they always rated eye contact higher as compared to no eye contact condition. So somehow we saw a differentiation between objective and subjective measures. So our engagement ratings on the one hand and gaze queuing effects in some experiments. Now, these engagement ratings, interestingly, have been also associated with EEG patterns. So we have observed in alpha frequency analysis, in the alpha frequency band, that eye contact condition actually modulated the alpha frequency. And then we also observed with eye tracking data that participants attended more, had longer fixation durations on the ICAP head when ICAP engaged participants in eye contact. So to conclude from this line of research, and I'm sorry, my presentation was jumping back and forth. What is important is that what we found is that mutual gaze actually is processed as a social signal. And that's quite striking, because if you think about it, these are just two cameras of a robot, and somehow they affect the way people attend to the robots, to where those cameras are looking and whether they're looking at you or not. The mutual gaze affects attention orienting, and it does increase subjective experience of engagement. Okay, so the joint attention, as I mentioned, is a mechanism between two people. So on the one hand, we follow others, but on the other hand, we also lead others in joint attention. So in the previous experiments, ICAP was leading our participants to engage in joint attention. In another set of experiments, what we've done is the reverse. So this time, participants are leading ICAP into joint attention. And what we wanted to observe is whether ICAP being contingent on participants' gaze, so whether it follows or not, that will affect, again, engagement and other measures. So here, what you see in this experiment is a participant wearing an eye tracking glasses set. And what we've managed to do here, which was quite an achievement from a technological point of view, is that we managed to send a signal to the ICAP robot from the eye tracking glasses so that the ICAP would either follow participants' gaze when they choose to look to the left or to the right, or it wouldn't follow them. Now, the important manipulation here was that we gave the ICAP two identities, and in one identity, it would follow our participants' gaze in 80% of trials, and in the other identity so the first identity was called Jimmy. So ICAP follows, Jimmy follows in 80% of trials, and then the other identity would be Dylan, and in the Dylan identity, ICAP would follow only 20% of trials. Participants' task was just to freely explore the screen first, the two screens, choose an object that they like most, and then gaze towards that object as fast as possible. And then while they were gazing to the left or to the right, ICAP would follow or not. So this is how it looks. you will see in a moment that our participant is choosing with her eyes whether to gaze to the left or right screen. And in this case, ICAP was following her. Here you see her pattern of the circadian fixations. And so she looks to the left and then ICAP follows as well. Our dependent variable that we looked at was the latency of return saccades. So when participants return from the screen to the robot as a marker of re-engagement with the robot. And this is what we observed, is that people actually are faster to re-engage with the robot when they're being followed, but only in the condition that the robot was in general following, more likely to follow them, not in the other condition. In a previous experiment, before we ran this one, we also observed that there was a large effect of the identity. So people were actually much faster to, in general, re-engage to Jimmy as compared to Dylan. And here is a Godspeed questionnaire result, and I'm quite excited to show this to this audience, and also because Godspeed questionnaire is a questionnaire by Christoph Bartneck, who will be talking after me. So what we have looked at was likability and anthropomorphism subscales of the Godspeed questionnaire, and we observed that actually the robot that was following our participants more, so Jimmy, was liked more as compared to Dylan. We didn't see an effect on anthropomorphism, and the reason we think is that because it was in the end, they were interacting with the embodied robot, but in the end it was the same robot. So we sort of made a manipulation that we told them that it has these two identities, but physically they were interacting with the same robot. All right, so to conclude this part, gaze contingency of the robot influences re-engagements of participants, and people do prefer robots that follow their gaze as compared to those that don't. The last bit of empirical studies that I wanted to present here is as touching on a different mechanism than joint attention. A different mechanism of social cognition, or let's say phenomenon that is quite interesting. It's a phenomenon of reduced sense of agency in joint tasks with others. So what does that mean? Sense of agency is the sense of control over the effects of one's own actions. So when I press a light switch and I see that the light goes on, I feel in control over that action. I know that I am the one who produced that sensory consequence. Now, one of the interesting let's say paradigms to study sense of agency is a situation when you're in a social context and your sense of agency reduces. That's something that has been shown. And this has been shown to be an underlying mechanism beyond reduction of sense of responsibility. So, or let's say a shared responsibility. So if you think about like, let's say scenarios where, I don't know, someone on the street faints and nobody acts, that's because we have shared responsibility, and we think like, why should I act if there are also other people who should act? And so this kind of phenomenon has been implemented and operationalized in the lab in the form of, let's say, joint task, where you're conjointly with another person responsible for acting or not acting and having costly effects of your action or inaction. So in a paradigm that operationalizes this concept, let me maybe guide you through this. You're playing a game, and in this game, either you play alone or you play with another robot. And this is actually the only experiment I'll show you that is not with ICAP. It's with small Cosmo robot. It's a commercial robot. Just a small toy. In the individual condition, what happens is that you see a balloon that is inflating, And at some point, it will reach this pin here and it will explode. Your task is to prevent the balloon from exploding. Okay, so you need to stop the balloon from exploding. Now, the earlier you stop, the more points you lose. But when you stop the balloon at the very late point in time, you lose very few points. But if the balloon pops, you lose maximum amount of points, right? So you have to take a bit of risk, but not too much of the risk, okay? And then after each of these outcomes, we ask you how much in control did you feel over the outcome that you see. So you can do that alone, or you can do that with the Cosmo robot. So in that case, sometimes the Cosmo will act, and in that case, you don't lose any points. So that's great. That's the best scenario for you. The problem is that Cosmo doesn't always act. Sometimes it acts, sometimes it doesn't, and you don't know whether it will act. So it's a joint responsibility, right? Because you don't know whether the other person is going to act, or in this case, the robot is going to act. And so you need to make a decision whether I act or not, and when do I act. So this is how the experiment looks. You will see here on the screen, on the horizontally presented screen, the balloon that will be inflated. And then it will be growing, and then at some point, one of the participants, one of the agents will act. So at first, Cosmo gets ready to perform. So it wakes up, it goes towards the cube. You can prevent the balloon from popping by pressing on the cube. So the Cosmo needs to also be quite close to the cube. And now you'll see in the middle of the screen that there's a balloon that starts inflating, and then one of the agents has to act. In this case, it was robot, it acted, and so participants didn't lose any points. And now what you saw is that the participant was rating how much in control they felt over the outcome. What we observe in this experiment is that in the joint condition, their sense of control was reduced as compared to the individual condition. And this is something that has been observed also in human-human studies. So with the robot, we replicate human-human effects. This has not been observed when the robot was replaced by just a mechanical device, such as air pump, okay? So when we replaced the robot with an air pump, this effect was gone. Interestingly, when we did the same experiment within participants, so participants had 2 sessions, one session with a human and one session with the robot. We showed, so you might not see it very well, but there's a human here behind the occluder, and the reason why we put such a barrier was not so that the human wouldn't add additional social signals. And in this experiment, the effect was similar both for the human and the robot condition. So sense of agency basically is reduced in a joint action with the robot. I'm very sorry, but my presentation just keeps on moving on its own. Apparently my computer has its own sense of agency today. All right, so sense of agency is reduced in a joint action with the robot, and therefore we can conclude that the robot is somehow treated as a social entity because we observe very similar phenomena in a joint action with a robot as we observe with a human. Okay, the very last part of my presentation I wanted to dedicate to work that we're doing with the ICAP for clinical applications. So all this so far, all this work that I presented is these are very fundamental questions of very fundamental science, but I wanted to convince you that this kind of approach can also lead to applications for society and for healthcare in this case specifically. Because what has been done quite a lot in human-robot interaction and social robotics is implementing training, so robot-assisted training for kids diagnosed with autism. And that is because kids with autism are very happy to actually interact with robots and train their social skills with robots. They feel less intimidated by robots. The signals, the social signals that robot display are simplified, so maybe they're less overwhelming for kids, and therefore one can use this opportunity and train social skills for kids with diagnosed with autism. So I will not present data, I will just tell you this as a kind of teaser, because we are running currently this kind of training. We have implemented an entire setup in an institution where kind of rehabilitation, where they perform rehabilitation for children with neurodevelopmental disorders, including autism. And so in order to do that, we needed to design the whole setup, have kind of a possibility of children interacting with the robot by handing over toys, for example, and yeah, being able to manipulate objects together with the robot, being engaged in a joint task. But at the same time, we needed to make sure that it's a safe environment. So we needed to make sure that, for example, well, both for the robot and for the kid, so that if we allow for an interaction that a kid just passes an object towards ICAP, that, I don't know, the kid doesn't, for example, stick their finger into some of the joints of the robot, because that would be very dangerous. So we needed to build a barrier, but at the same time allow for joint action. So that's why we also built a little box here where kids can pass objects to the robot and vice versa. With this kind of setup, we can do all sorts of training of joint attention. Like you see here, the robot is pointing, for example, to a toy, and then the kid can pass that toy that the robot was pointing towards. So the kid needs to engage in joint attention. And that's something that we know that children diagnosed with autism have difficulties with. So in order to complete that task, they need to actually train their joint attention skills. You can train perspective taking, another mechanism of social cognition that is often children have difficulties with. So this sort of setup allows for multiple and various training protocols. I just want to show you the challenges that we needed to face, because we did this all from scratch. We needed to design the stimuli objects that would be graspable by the robot, that would be safe for the kids. Now we had an added complexity of the COVID pandemic, so we needed to make sure that we can sanitize all these objects properly, and so on and so forth. We needed to develop the robot behaviors that would be very natural and would be intuitive for the kids as well. Then the setup, as I already mentioned here, where this is the setup in preparation, and then actually mounting the physical setup here in the institution that we have been working with. An association, Don Orione, a religious association that takes care of rehabilitation for children with neurodevelopmental disorders, among others. And then finally, the setup is finalized, and we are currently running this this training for kids, and I hope that in a few months from now we will be able to provide data on this. General conclusions that I wanted to give here. In general, embodied robots provide an excellent opportunity for us, cognitive social neuroscientists, to study social cognition. And that is because they provide ecological validity, because they're embodied. They have physical presence in contrast to just stimuli on the screen. So for fundamental science and social cognitive neuroscience, they're like sophisticated stimuli that offer these great opportunities to study social cognition. From the perspective of human-robot interaction, robots, what we see in our results is that they actually can be interpreted as social entities. Their gaze is interpreted often as a social signal, and sometimes people adopt intentional stance towards robot, but what we see mainly right now in our data is that very much depends on individual traits. And then finally, the last point that is very important is that apart from fundamental science, we can also use robots to help in clinical applications and train social cognition, for example, for children diagnosed with autism. So in terms of like a more general overview of the field and where we're going, we're very much still in the laboratory settings, and those are very controlled experiments. We need them quite a lot because we need to understand the exact mechanisms of social cognition when they happen in human-robot interaction, and that for that you need to have protocols, experimental protocols that address and isolate exact those cognitive mechanisms. Then we're kind of going in the direction of first application scenarios. We develop these training protocols, and we, as I have showed you, we are slowly getting there, but they're still in quite controlled environments, and there's still a very long way to go into the wild with, let's say, AI competent or AI endowed robots that are autonomous and that they can actually help us in assistance. So the idea is that first into the wild would go into more kind of real world, but structured environments such as hospitals or airports. And then finally, the biggest challenge is to introduce robots into home environments that are less structured, that are very variable from home to home. And that's a big challenge for all the disciplines that I mentioned: robotics, AI, psychology, cognitive neuroscience. But our ultimate aim is to get there at some point. I would like to thank my team in Genoa. These are people that have contributed to all this work here and that I presented here. I would like to thank the European Research Council for supporting this research. And finally, thank you very much for your attention.
Thank you very much, Agnieszka, and special greetings to your team. Now, of course, because of the pandemic, you cannot hear applause, but of course, in normal situation, you would hear at this particular moment big applause. So only silent, let's say, virtual applause for you. I see that we have a couple of minutes, so we can allow for a short discussion. I see that on the chat we have some comments and questions, and also I see that one person raised up hand. So would you agree to answer these questions? Okay, so Angelica, I saw Angelica. No, let me see. Where is it? Someone. No, so situation has changed, but on the chat we have regarding anthropomorphism. Do you think it would have a placebo effect if the robot was taken out of the room and brought back, but the human would be told it is a different robot? Which would the likability affect the anthropomorphism?
I think that would be, yeah, probably more likely to observe the effect if we could actually make this manipulation that people believe that it's really a different identity. But still, I mean, the robot looks the same. So I think we have, interestingly, we have run a study like that one before with screen-based stimuli. So the robot was also contingent on participants' gaze, but on the screen. And we managed to also find an effect on anthropomorphism in that case. But I think that is probably because on the screen you don't have so much information about how the robot really looks. It was just an avatar and it was just actually the face. So it was easier to believe that it was a different robot. While when you see the entire embodied robot in front of you, I think it's hard to have a modulation of anthropomorphism in that case.
Thank you so much. Anyone wants to ask a question? If not, I have also a question. So I would like to ask you, Agnieszka, about this concept in intentional stance, because you use this concept by Dennett, but for me, I see a lot of similarities to anthropomorphism. What is the difference between intentional stance and anthropomorphism? Because for me, it's very, very similar. Okay.
Yeah, thank you very much. And I think that discussion can also be then later brought in after Christoph's talk. Intentional stance, in my view, is just a subset, it's part of anthropomorphism. So anthropomorphism is more than intentional stance. Anthropomorphism is attributing anthropomorphic traits to non-human agents, and they can be physical traits. We can see faces in the front of the car, right? And that's also anthropomorphism in a sense, but that's just physical features. And intentional stance is like a subset of these phenomena. So yeah, it's part of anthropomorphism. So anthropomorphism is a much more general concept to me.
Okay, perfect. So I think we are going to continue and we are going to explore this topic during our discussion. Any questions or comments or, oh yeah, we have one. So robots are expensive to produce today, of course. Can you use virtual reality to teach kids how to behave with robots? Can robots teach autism kids how to let it go and dance?
Yeah, great question. I think it's an interesting question because there are approaches of using virtual reality for healthcare applications, and certainly there is a potential there, and certainly cost is a factor that needs to be taken into account. I personally believe, and we are going into running some studies to actually examine that. I personally believe that embodiment matters. So the fact that you can share the same environment, but the real physical environment, and manipulate objects. That's why we, with the study or the training protocol for children, it was very important for us that kids and the robot would hand over objects. If you manipulate same objects, and if you know that the robot can change your environment, that makes a difference for an entire plethora of cognitive mechanisms, I think. But it's a question that needs to be answered certainly empirically. We have some preliminary data that show indeed that's the case. We show effects on engagement, for example, when we compare an embodied robot with its like just 2D representation on the screen with exactly the same task. So yeah, I think VR is certainly a way to go, but if there is a possibility of using robots, it might have an additional benefit of the embodiment and physical social presence.
I have to, sorry. So we have to move to our second speaker. But if someone wants to explore this topic of VR, or virtual reality, I recommend to listen and watch our previous meetings, because 1 week ago and also 1 month ago we had 2 meetings, HumanTech meetings, regarding virtual reality. So I really recommend to watch and listen on YouTube. You may find these recordings. Okay, once again, thank you very much, Agnieszka. Our next speaker will be Christoph Bartneck. Christoph from New Zealand, so very remote country. So let me present very briefly Christoph. So Christoph Bartneck is Associate Professor and Director of Postgraduate Studies at the HIT Lab NZ of the University of Canterbury. He has a background in industrial design and human-computer interaction, and his project and studies have been published in many leading journals, newspapers, and conferences. His interests lie in the field of HCI, science and technology studies, and visual design. More specifically, he focuses on the effect of anthropomorphism on human-robot interaction. He has worked for several international organizations, including the Technology Center of Hanover, LEGO, Philips Research, the Eindhoven University of Technology, and many, many others. Christoph is an associate editor of the International Journal of Social Robotics, the International Journal of Human-Computer Studies, and Entertainment Computing Journal. Moreover, Christoph is a member of many scientific organizations in New Zealand. You may see on the screen the details. His work is regularly published in the New Scientist, Scientific American, New York Times, The Times, BBC, Washington Post, and many, many others papers. As you may see, interest of our next guest is very similar to the previous speaker. So I hope it will be very interesting talk. And after that, of course, a discussion panel. So there are Christoph, our virtual floor is yours. So please, I need to stop my sharing my screen. So go on.
Cześć. Good morning, everybody. Okay, so now I have the task of getting my screen done.
What's the pandemic situation at the beginning? Tell us, because it's in Poland, okay. Situation is horrible.
Okay. Right, so is my screen coming across all right?
I guess, I'm not sure. I see it's visible, but something is, I think, wrong, because we see only two small screens.
Okay, sorry, my bad.
Okay.
The wonders of technology. Okay, let's try this way. How is this?
Okay. Not exactly. Something is wrong.
Okay, never mind. I'm trying a new trick here, trying to have a sidecar second display so I can screen my presenter screen. Hold on a second. I'll get this done. No worries.
Okay.
That's when you want to do too many tricks at the same time. I want to disconnect this. I'll just have to do it without my presenter screen. So how are we doing now?
Perfect.
Okay. All right. So I'm flying a little bit blind here because I don't see my presenter notes, but I hope I can make it work. As I was already introduced, I spent quite a bit of time in various organizations around the world. I worked for LEGO, which was particularly fun. I worked for Philips Research, the Eindhoven University of Technology. I spent some time in ATR in Japan, and now I'm in the University of Canterbury here in New Zealand. And similar to Agnieszka, I've done quite a number of studies that investigate one detail or the other of human-robot interaction. And the pattern is very often quite similar, is where you have a concept of human-human interaction, may it be gaze or any number of things. And you look at how humans do this, and then you compare that to how humans do that with a robot. And sometimes you find that it's very similar, sometimes it's not. And this is all very much about this phenomenon that, in a way, we treat robots as if they are social actors. We treat them as if they were humans, but we also know they're not. So we're kind of like stuck in between. And there's a numerous number of studies that do this. I've done plenty of these. Agnieszka has done plenty of these. And I guess several of our audience members also have done plenty of these. And yeah, this is how we do science currently. I could show you, a number of studies that we've done recently that investigate, again, one detail or the other. But recently, I've also become a bit more interested in kind of like putting my head over the water and look around a little bit and see what else is going on. And what you encounter then are kind of these interesting things like, this was a poster presented, and it was essentially about fMRI scans, as Agnieszka already showed how they're being used. And what they've done is they took a dead salmon and they put it onto an fMRI scan and scanned it, and then showed pictures of people in a socially inclusive or exclusive situation, and asked the salmon how the people in the picture might feel. And the dead salmon was unfortunately uncollaborative. It did not follow the experimental procedure, and so the experiment was a bit of a failure. But nevertheless, they did the scans and ran some statistics on it, and they could show some significant differences. And so what this, of course, highlights is that methodology can be tricky, and fMRI scans are also tricky, particularly around the interpretation. So when you stuck your head over the water and you see kind of science in a bigger perspective, you come across this sometimes humorous results. Here is another one. I found this recently and I was really baffled by it. This is the robot building in Bangkok, Thailand. And this building hosted the Bank of Asia. And it was built to represent a robot. It looks like a robot. So why would you do that? Why would you make a building that looks like a robot? That does seem, I'm not sure for you if it's strange for you. For me, this is rather strange. But of course, robots represent something. And it is this representation that makes it attractive. So this idea that robots are the future, and therefore the bank wants to look like the future. So therefore we take a building in the shape of a robot so that it represents the future, and the bank then can claim like how super duper forward looking and futuristic and forward thinking they are. Certainly there are thought leaders and probably also brand disruptors. So yeah, robots have this interesting aspect that we look up to them. And of course, we're being, in a way, largely influenced by the media. So the people who made this decision probably watched many science fiction films, and is a particularly nice graph here about all the different robots that you can see in science fiction. And if you ever do find WALL-E, let me know, because I spent already like a good 5-10 minutes staring at this image and I have not been able to find WALL-E. So the point being here is that many people in our experiments, many people overall, are heavily influenced by how robots are being portrayed in the media. And that has a profound impact on how we deal with them and how we approach our studies, how politicians make decisions about funding. It really has a lot of impact. Now, we recently summarized or tried to summarize many of these, how should I say, studies in a book called Human-Robot Interaction, an Introduction, which is the first textbook on human-robot interaction. And you see on this open page, we've got a couple of robots already in there now. Paro and Keep On. This book's tried to kind of bring this together into, again, a bigger picture about the whole field. What are you doing here? Why are we doing it? And we do report, indeed, on many of these individual findings and trying to bind it together and wrap it up. But one thing that I discovered when doing this book is that we created a timeline of social robots, because we made quite an effort to include a large number of photographs of these robots in there, and ended up around being 90. And I can never recommend to ever do this again, because tracking the copyright of all of these images was quite a nightmare. But we succeeded, and so this is a very nice book also because it has many pictures, and students love many pictures, I guess. It is kind of attractive. And so, for example, we got here Honda Asimov, who existed from 2000 to 2018. And what we observed is that all of these robots that we kind of showcased are gone. They're dead. They no longer exist. Even something like Honda, who's been working on this for so many years and made so many great contributions, had such a great robot, they stop. So all these social robots died. And that worries us, because why do all these robots die? Why does none of them succeed? And that's really a really existential question, because if we're all doomed, if nobody ever makes it, then in a way we're wasting our effort and our time. So this is a really big and important question about why do all these social robots fail? So I figured, let's have a look at an example. Here, this robot, this is Jibo. And this is, in a way, a really nice example of a story of an attempt to bring a social robot to the market and make it work for reals. So this whole thing started off as an Indiegogo campaign back in 2013, 14. And they raised an enormous amount of money, $5 million US. And this was headed by Cynthia Brazil from the MIT. And we all know Cynthia. She's a world-class researcher. And adding to this 5 million from Indiegogo, there was another around $60 million US in venture capital that was invested in this robot. So they really had the money and the resources to do this and to get it right. And they tried really hard. So here's a little video clip of Cynthia introducing the Jibo robot, and I hope that this will come across.
Jibo, please introduce yourself. Sure. Hi, my name is Jibo. I'm the world's first family robot. Yeah, so I mean, this is actually, we developed several prototypes on the road to where we are right now. Certainly, we've done testing all along the way. You know, we very quickly found, and this is just reinforces a lot of what I found as my work at MIT, people want to treat Jibo like a someone, not a something, and they often, at the end of the
Okay, you heard this. This is a very important thing, and I guess Agnieszka would also, agree to, is that people treat robots as a someone rather than a something, or at least somewhere along the spectrum. It's not just as a pump or as a washing machine. It's different. So they made it to the cover of the Times magazine, the best invention of 2017. So they got the money. They got the promotion. I mean, they get the attention of the world on them. And they even got very, very smart people like Cynthia from the MIT Media Lab. I mean, how much better does it get? I mean, what else is there that you could do right? I mean, they did everything right. But they also shipped it. I mean, it's also great. I mean, there's so many campaigns that just go nowhere and they die, and they never actually ship a product. Well, they did. They actually produced it and they made it. And here's a review of Jibo.
In July 2014, men did not yet know the dangers of backing just any random Kickstarter or Indiegogo campaign. And Swimming in childlike naivety and blind optimism, over 2,500 people backed Jibo, a social robot companion that the creators, Jibo Inc., promised would do everything from making video calls to reading bedtime stories. And this was long before the Google Assistant or Amazon Echo existed. Now, for my part, it was pretty obvious that Jibo was too ambitious to be anything but an enormous belly flop onto a bed of hot coals. But coming off of the success of my then recent flaying of the Brunton hydrogen reactor, I was looking for a way to up the ante. I was looking for something even dumber to roast. So I bought one. 3.5 years later, my very own Jibo finally showed up. Was it worth the wait? Was it worth $900 US? Of course not. Don't be a Jibo. This video was brought.
So, as you see, the reception of this robot was not particularly positive. And in 2018-19, Jibo was stopped. The whole thing shut down. And again, they did everything right, everything that we know by the book, that you should be doing, they did, and it still failed. Now, and as recently, this is where it gets interesting again, because Jibo was bought up by NTT Disruption. NTT Disruption is a new company from NTT. NTT is the classic, the traditional Japanese telecommunications company, and they created a new company called Disruption, which disrupts the market, as you might guess. And one of the things they did is that they bought up whatever was left of Jibo and now promote it again. And they made a manifesto, and I could not possibly withhold this gem of marketing. So yeah, so this is how NTT Disruption sees itself.
What a word. To you, there's no till where, no till here. Impossible, unthinkable, crazy thing. All those words you deal with every day. They don't annoy you, they inspire you. They don't shut you in, they set you free. Listen, you need limits to be who you are, to disrupt, to create, to invent. You, the old rules breaker, you, the new rules ruler. You don't live in the real world, some may say. They just ignore this world of theirs is changing. And thanks to people like you, like us, like her, change is happening for good. We, the people who see things differently, those who say no to no. You are just a few, some may say. Yes, we are. But those few will create today what really matters for tomorrow.
Yeah, so that's NTT Disruption for you. And I made a particular podcast episode about Jibo. So if you want to hear the full story, please have a look at the HI podcast series. Now, what this really means is that when I asked them, so, okay, look, you bought a robot that did everything right and completely failed. What are you going to do different? How is things going to be different now than when it was tried the first time? And they come back with the exact same application areas that Agnieszka already mentioned, healthcare, education, and so forth, where, these robots would be used. And if they use it, it's going to be different. But of course, Jibo was already intended to be, applicable for schools and for healthcare and so forth. So we're all looking at the same application areas. We all fail, and we keep on trying and doing the same thing over and over again. Hence the title of my talk, Same but Different. Here is now Pepper in a store. And it can be argued that SoftBank Robotics, who bought up Aldebaran Robotics back then, SoftBank is a telecommunications company in Japan, and they sell mobile phones. And largely this could be interpreted as, well, look, they've got some robots and they were able to put them in the shop floor and people liked it and they were excited about it and they got all these customers in their store, and that for them was good enough, that served the purpose. And we might still be happy to be able to do some research with it. But fundamentally, this is just a marketing exercise, same as now Jibo for entity disruption. Entity disruption is a marketing exercise. This is just to look sexy and to claim that you're innovative. And robots then are being used for this purpose. And again, we all think like, oh, but if we do it, it's different, right? Because, all the other failures that happened before, that was not that we are different. And so here we go again. Here in Christchurch, the airport bought some Pepper robots, and they bought them and put them up and called this all being disruptive and tried them out for a while. And then, of course, they disappear because they can't really do anything. They don't really add any real value to the airport. This has been a very expensive learning exercise for the robot, I guess. And again, the main emphasis has been marketing, marketing, marketing. And for that, maybe robots are helpful, but serving a real purpose, being actually helpful, I think we're still quite far away from it. And of course, there are then ways out of it. And one of the smartest way out of it is Sony Aibo, a robotic dog. Because here, finally, you can dial back the expectations towards this robot. It's not expected to be a humanoid. It's not supposed to understand your speech. It understands your speech as much as as a dog would do. Sometimes it does, sometimes it doesn't. And from that, the only real interaction that worked over long term has probably the parasail. And again, the reason why this one has been to some degree successful is that it doesn't actually do much. It just purrs and moves a little bit, and that's it. It doesn't do anything else. But since nobody ever really interacted with a seal before and nobody's got a point of reference, this works. And there's no speech, no nothing. It's just cuddling, purring, and that's it. So on this level, it sort of works. But of course, they're still quite expensive. So you don't see them. You can't go into a shop and buy them directly, right? Well, that brings, of course, the question up, well, can a robot actually be useful while only being social, like only being a social entity? And maybe the answer is no. Maybe it does require a function like floor cleaning. And if it does have that, then maybe we get a bit of social interaction as well, but predominantly the focus should be on functionality. But if we take that approach, then what we do is that, well, doing things is hard. It's really, really hard. Even cleaning the floor is hard. And many activities that we do and want to do, like having a robot doing the dishes or cooking us a meal and all the things we want, is just really, really hard to do. And the technology is not there yet. And that's pretty much it. So the really key question here, and this is probably the key graph in my whole presentation, is that, yes, we can continue to put effort into our robots. And yes, we do make some progress in terms of the intelligence of the robot. But the question is, what is the shape of this curve? Will this curve actually ever break through the ceiling of, well, this is now acceptable for a robot? And with acceptable, I mean long-term interaction. I mean, yes, you can wow people for like 5-10 minutes and they think, oh, this robot is so smart and it's so intelligent. But give this robot to the people for like a month or even 2 or a year and ask them again, do you think the robot is intelligent? And people probably come back like, no, it's not, okay, it says like a couple of behaviors and we've seen them all. And now we're bored and now we put it away. So the shape of this curve is really, really interesting. And again, it's easy to be critical and ask everybody's a critic. And, if you think back many years ago and you would promise people like, look, we can build a computer that can play chess or beat the master in Go, you would say, wow, no, computer can't do it and they will never do it because they're stupid and they can never reach that level. And then they did, and they made it. And so there is progress, yes. So we can't deny there is progress in intelligence, AI, but it certainly is not going as fast as we want it to, and not as fast as we need it for human-robot interaction. And so there are, of course, ways around it. And so things that have been done in the past, for example, is something that's called as fake AI. This is an example of my own little work here, where we had robots talk to each other and humans. And one of the problems is that maintaining meaningful conversations, again, is really, really hard. So we essentially abandoned logic and reason and went straight for religion. So when you talk about mystical religious things, you don't necessarily need to make sense, right? You can just say stuff that sounds amazing and relevant, but it doesn't matter, right? So here what we have is simple word spotting. So if one of the robots picks up a word,
when the voice goes past, Jesus was found alone, and they kept it closed and told no man in those days any of those things which they had seen.
And it is who has created the heavens and the earth with truth, and on the day he says, Be, it is. His word is the truth, and his is the kingdom on the day when the trumpet shall be blown, the knower of the unseen and the seen.
The point is, you avoid having to make sense by just escaping into mysticism. But there are also other ways that you can avoid or fake ID. And one of the most common things, of course, is Wizard of Oz, where you have actually a human in the background controlling the robot. And then the robot looks particularly smart, and you think that this is now a smart robot, but actually it is really just a human in the background doing the all the intelligent things. And of course, Wizard of Oz has been taken from the movie The Wizard of Oz, because in the one towards the end, they come to the Wizard of Oz and see when the little dog takes away the curtain and reveals the person in the back who controls the big scary wizard. And he even still makes an effort in saying, pay no attention to the man behind the curtain. Of course, at some point this becomes clear. And yes, we sometimes need to do this because HRI studies require a certain amount of intelligence. And if the speech recognition just doesn't work well enough, then yeah, you have to put a human in the loop to solve it. But then again, we give people the impression of how robots work, which when they actually don't work, we feed into these ideas about expectations that are more equivalent to science fiction than to reality. And this will bite us back because, well, when people then buy the robots and take it home and suddenly they see it's not that good, not that interesting, or not that intelligent, then they'll be quite frustrated with the product. Another way that we are avoiding this is actually turn the whole thing upside down, in which we essentially claim that, okay, this is an autonomous robot and it has limited functions and it cannot really do much. And we say, no, this is not a bug. This is actually a feature. And Agnieszka already showed it as well. You take the robot and you bring it to a special interest group, like children with autism. For some reason, they like it, or people with dementia. People with dementia, they don't care if the robot gets repetitive because they don't remember. So essentially, you turn the robot's problems towards a special user group that doesn't care about it, or even maybe like this particular limitation. But of course, it's never the intention. It has never been the intention for a robot. So essentially what we have is here, we have got a solution that is trying to look for a problem So we've got a robot, it can do certain things, but it is limited. So then we could try to figure out desperately, okay, in which context can this robot actually make sense? In which context can this work? And then we kind of find these niche applications where this could actually be useful. But again, this is just a workaround. What we really want is the actual interaction with people, not just having to fake it. And so this is now, of course, again, in a way, this is a really nice ticket for Agnieszka and myself, because in a way, we'll have got quite a job security, because we can keep on working on this forever and we will never run out of research questions or problems, because we can never claim that that the work is done. Every HRI paper says, okay, more research is necessary, and this is going to continue for quite some time. So very convenient for us. But of course, the question is, will we ever get there? And this is a nice little cartoon, and I found particularly interesting. And I am completely this. I'm a fiction writer in the grant proposal genre. So when we write grant proposals, we tell stories and make promises to our funders, particularly politicians. And with robots, we tell them all sorts of stuff, like all the great things that our robots will be able to do, and people buy it, well, to some degree. And this is interesting, but also sad, because in a way, if we would have to admit to what robots can really do and what we are really doing, I doubt that we will get any funding. So we have to play into this myth and idea about how super duper robots will be for funders to get interested and pay for our research. And I guess if there would be a more rigorous testing of whether the results actually met the expectations or the promises after the project is finished, then we would be in real hot waters, because it is quite problematic. So that's the thing. Robots, they're so sexy and so attractive, and politicians love it, photo opportunities, the media loves it. But so there's a lot of interest in it, but at the same time, we're not really making that great much of a progress. And then in the end, we really have to be careful with frustration management, not including our own participants, because when they come into the room and they've got this expectation about all the great things that a robot can do, and then it can't, then they get disappointed, and so does everybody else. And again, it becomes so critical when we then turn this into a real product, because there's a big difference between being in a lab, interacting with a robot and having a great experience, and going to a shop and putting the dollar on the table and say, I want to buy this. Very big difference. And because we can definitely demonstrate that all the robots, even those that are indicated or were meant for, let's say, more research, as a research platform, like Baxter and so many others, they also still all failed. They all gone. Nobody could make a business out of it. And the problem really is that when we maintain this myth about what robots can do, and people, let's say, take this for reals, then we get into trouble, because, look here, we have a person who has got some very interesting ideas about how to cure COVID.
And then I said, supposing you brought the light inside the body, which you can do either through the skin or in some other way. And I think you said you're going to test that too. Sounds interesting. Right, and then I see the disinfectant, where it knocks it out in 1 minute. And is there a way we can do something like that by injection inside, or almost a cleaning? Because you see it gets in the lungs and it does a tremendous number of lungs. So it'd be interesting to check that. So that you're gonna have to use medical doctors with. But it sounds interesting to me. And so we'll see. But the whole concept of the light, the way it goes in 1 minute.
So I'm going to miss Donald. He's giving me so much comic material. I mean, if it wasn't so sad, it would be funny. And yeah, but you see, the point is like these politicians, I mean, just turn this around. Think about it. Like now a politician would stand in the crowd and say like similar stupid things about what to expect of a robot. right? It's quite conceivable that if we lead on to this narrative about what robots can do, that we get a similar stupid speech about the future of robots and all the great things they can do. And that would be, of course, terribly, terribly embarrassing. And if you think like, oh yeah, of course, that was just idiot Donald, what that has to do. But even here on my front door, this is now a story about a supercomputer that was proposed to be placed in Christchurch. And it was called Zach. And Zach was meant to do a great deal of things. And here we've got Albie Whale, who tells you a little bit about what his supercomputer is going to do.
We're going to remove the people from the equation everywhere but customer support. Put a machine in charge. So the idea is take the links out where we've got a human involved, replace it with a machine and see what happens. Is it going to be a colossal disaster or a success? We'll find out. We're taking away the management team, we're removing the board, we're taking away the accounts people, product procurement, configuration, provisioning, customer support, social media management, all of it. And we're going to give it to the computer program and see what it does. But beyond that, we're not going to watch it, we're not going to stop it. We're going to let it do what it wants and what it sees to be fit, provided it can present us with a reason for why it's doing it. So it wants to validate people's accounts. Why is it doing it? If it doesn't want to connect with people, why does it want to do it? All those sorts of things. So there'll be a human oversight, but we're not going to watch it. We made terrible talk for one simple.
So here we got a company which was called the Terrible Foundation. And again, don't be turned off by the name. I mean, Elon Musk's boring company produced flamethrowers, so don't get caught up in the name. But this company idea was take AI and give the whole management of a company to this AI and just let it go. Replace the CEO with the AI. And they actually did that. They actually did this. We've got minutes of the meetings in which the president, the CEO, Zach, was present and was hosting the meeting. And yeah, so they definitely went on, got a lot of media hype, and they were raising money and doing all of these great things. And they were supposed to go into a big heritage building, and the biggest, fastest supercomputer in the Southern Hemisphere was supposed to go there. And then they looked for application areas, and hey, here we go again, healthcare. Why not? Here we've got an actual doctor who actually tried the system, and Zach, the supercomputer, was intended to help with the taking notes of the meetings, which is indeed a real problem. Like when doctors interact with patients, they spend a lot of time just documenting everything, writing everything down. And if you can skip that and actually spend more time talking to the patient, that would actually be great. If you then, after the consultation, you would just get a summary of what was said, and also the recommendations about what the patient should be doing, and so forth. And so this doctor in Christchurch used Zach, and here's his report.
So we started off to train Zach, and were amazed by his ability. In no time at all, we trained him to take notes in SOAP format. That's subjective, what the patient said; objective, what the doctor found; assessment, what the doctor thought the findings meant; and a plan, which speaks for itself. And this is the standard format that most clinical notes follow, even if the doctors don't realize it. And it was pretty amazing stuff right from the start. So we decided we would actually study this to see if it was as good as we thought it was. And the way we did this was we got 5 sets of clinical notes that were created using only Zach listening in on the consultation. And we got 20 sets of clinical notes, 5 each from 4 different doctors. We told a panel of 15 medical students that we were doing an audit on notes quality, and that we were just checking to make sure that the doctors were being as honest as they should be in terms of a notes audit, and that students were really checking up on that. And the students assessed each of the clinical consultations in random order against a set of criteria set by the Royal New Zealand College of General Practitioners. We were amazed by the results. We knew Zach was good, but what we didn't realize was that Zach beat all 4 of the doctors with whom he'd been compared.
So see here, they actually try to do an experiment with actual participants and data and everything. And Zach the AI beat them all. Now, one has to consider here that the way Zach did essentially the transcription, and as a matter of fact, any kind of interaction with Zach happened through email. So you sent an email to an email address, and then you get a response. And the response could vary between a couple of seconds, a couple of minutes, hours, days, whatsoever. So the interaction was, in a way, a Turing test, actually. It was interesting. And of course, some of you might have guessed already that Zach actually never existed. The person behind Zach, Albie, did all of this work pretty much just by manual labor. So this was a whole Wizard of Oz thing. So again, we've got these ideas about AI and all the great things it can do, and we throw away our disbelief and suspend it and go into action as if it was possible, as if this was true, as if this AI can do all of these great things. And then there are people who take advantage of this and exploit it even. So they've started a company called Omega Health, and they were trying to attract venture capitalism to make this a reality. So this is the typical fake it until you make it approach. So you pretend that you already got a solution, and then once you got the money, you try to actually do it. And very often, of course, you fail with this. But again, see, people get caught up in these dreams so easily. It's really, really dangerous. And in the end, of course, this whole thing, in the end, it didn't work out, obviously, and the whole terrible foundation was disqualified, and it was taken out. Their charitable status was taken away. The owners were banned, and it really had quite a few consequences. There were never any kind of court cases, and the people never actually got sentenced for anything, possibly because they never actually managed to attract money, so they never actually wasted monies from other people, but they certainly tried very hard. Now, again, the question now comes, well, if Jibo didn't make it, what kind of robot ever can? And here we have another robot. Here's Amazon's Echo 10, which is a smart speaker, as we have so many right now, maybe HomePod from Apple or Google Assistant or Amazon Alexa. They all exist, and they all do this voice-based interaction. And now this even has a screen that rotates and tries to follow you and look at you. It's a robot, okay? It's a clear robot, and they're putting it into the market. And the question really is, do you need this embodiment at all? Yes, I mean, you need a speaker and a microphone, and it has to be placed somewhere. So putting it into some sort of enclosure, yes, maybe that's necessary. You could potentially hide this in the ceiling if you wanted to. But right now, it has some sort of embodiment. It's standing there and sitting there. And of course, the difference here is that with Alexa, they already ship millions of devices. So see, one of the approach here is that all this company like Jibo and others, they know that they can never create enough intelligent behavior to keep people entertained. And so what they always do is crowdsourcing it. So you say like, well, look, we open our platform up to all these developers, and then all those developers go out and do this great work, do all this great intelligent behavior. And then, it grows that way because the company itself will never be able to create enough content. And for something like a platform like Alexa, this might even work because, again, it's a critical mass problem. So if there's enough users and you can sell any behavior to them, you can sell a function to them, this might be interesting for developers. But for something like Jibo, where only a couple of thousands were sold, it would be a waste of time for developers to try to sell anything there because your customer base is extremely small. The same thing holds true with probably the most common robot in HRI now, and Pepper. They also have an app store, but how big is the market? Well, not very much, because it was only ever researchers who bought them. And how many researchers are there? So this approach of crowdsourcing the problem of implementing intelligent behavior doesn't really quite seem to work for the robots that we work with. And again, the functionality with these kind of smart speakers is also, well, limited of things you can do with voice and voice only. It is literally just only there to listen and to talk. It's a completely conversational agent. And as soon as it's conversational, you have expectations, right? Because the only other animal, or the only animal that really uses speech well is humans. So if something talks, you expect the same level of intelligence. And yes, if you put this in the house of people, in the beginning, they're all excited about it. Let it be there for a year and still look at what people still do with it after a year. It will be very different and it will be very limited of it. So, which brings me kind of to the point, like, why are we having robots anyway? I mean, what's the point? Because for pure conversation, the Echo Dots and the Amazon Alexas, they work and they do the same trick, you know. And for functions, maybe having dedicated machines, like a dishwasher, like a washing machine, like a floor cleaning robot, something that does not have to be social, that can just do its job, is probably better. So where then what's the whole point of social robotics then? And in my view, it is touch, because that's the only thing that robots can do that a smart speaker really can't. It doesn't really make much sense to touch it. Having said that, I probably, would argue that people have more interactions, physical interactions with their smartphones than with their partners. So in that sense, technology already took over that aspect. But still, so touch would be the only thing left. And when I saw Agnieszka's presentation about having to put a shield between the robot and the children because it's dangerous for the kids that they maybe get their fingers squeezed. Yes, that's probably true, but also, yes, that's really, really sad. I mean, that's really bad that we have to do that. And the only robot that I know of that ever survived dealing with children is ATR's robots. They're the only ones who ever made it to a kindergarten and back and survived. But still, touch is really, really important. And I've got a little video clip here. No, that's actually first. We tried it here as well. And so this study was, see, the idea here is that, I mean, you can try it right now. Try to tickle yourself, It doesn't work. Our brain is not wired that way. You cannot tickle yourself. It just doesn't work. So you need another person, another entity to do this. And then the sensation happens, then it appears and it makes sense. So in this particular study we had, you either get this head massage by a robot, by another person, or we do it yourself. And we then looked at, well, how is this experience different? And again, you see, this is the same pattern again, as I talked about, like you've got a human phenomena like tickling, and then you replace the human with a robot and you see if you get the same result. And then you take this as an indicator for how a robot is or is not like a human being. It's the same pattern over and over again. And the reason why we needed to use this particular device is, well, it is actually quite an interesting experience. The scalp is surprisingly sensitive and has a lot of sense. It's just very sensitive area, surprisingly, and it's really quite ticklish. And also, to be honest, the robot can't do a massage, not properly. And therefore, this kind of device helped us to feather off the incompetence of the robot. Yeah. So again, doing it for real, a robot actually doing a good massage is really hard. Yeah, you can sit in massage chairs, but the massage chair cannot actually sense where you are tight in the shoulders and then search for it and then particularly apply pressure in the right amount. Nowhere near. It has a generic program and, it presses you somewhere, somehow, and you can maybe vary some parameters. But it's nothing even close to what a human would be able to do. But then again, here's an example of, we had Papero for a while, and I took it out of the box, I put it up at home with my kids, And this is the interaction, live. I mean, I just put it up, switch it on. It was not scripted, no experiment, just out of the box behavior. So again, my kids decided that the most appropriate way to interact with this robot was to kiss it. And again, completely unscripted, but it was their idea. It just, the robot had an LEDs to indicate a mouth, and there you go. So yeah, to some degree it works. But again, how long will it be fun to kiss a robot? I mean, at some point, my kids will get bored with it, and that'll be it. And which brings us back to here. Long-term interaction. It's fulfilling, interesting interaction. And to do this and to maintain this is really, really hard. And I am unaware of any robot that actually ever really solved this problem. So the question really is, coming back to it, what is the shape of this curve? Do we ever have a chance that we will somehow come over this threshold of where we think like, yep, you know, it is intelligent and it's intelligent enough and we like this and it's okay. So if you want to know a little bit more about these kind of higher level topics, I recommend that you have a look at the podcast where I speak to quite a few people. And I saw in the audience list already, Guy Hoffman is out there. So hi, Guy, how are you doing? I did an interview with Guy Hoffman as well. It is up there. So yeah, have a look at that. This might be quite interesting for you. Or have a look at some of the books. We recently did a book on Introduction to Ethics in Robotics and AI, and there's an upcoming book about robots in education. Here's the cover of the German edition that will come out next year, where we again try to treat the topic on a more higher level and not just based on the individual study. So in conclusion, as you've seen, I didn't really talk a lot about the actual individual studies that we do in my lab, and you know, just have a look at the papers. There's plenty of them out there. But what I guess sometimes it is important is to look up out of your own work and put this into the bigger context of what we're doing. And I am concerned. I am really concerned about the field because we can keep on doing what we're doing endlessly, really. I mean, we can keep ourselves busy with this forever. And we'll probably make some progress, and probably we create understanding of how people treat robots a little bit better. And maybe in the course of doing it, we even learn a thing or two about ourselves. Because if you understand, if you're able to build a robot that acts in a way like a human, you must have understood how humans act. So in a way, this is an exercise of understanding ourselves. And for that, it might be useful. But nevertheless, the fact that all social robots that were ever put into the market failed is a clear signal that there's something wrong, that it's not working, right? Not to the degree that people would be willing to put actual cash on the table and buy it because they think that they want it. And the only way out so far is offering them some real functionality that is useful for the people, that actually works, like floor cleaning. But the developments around that is still indeed far away, and it's not really happening yet. And even the conversational agents. Yes, you can ask Alexa, what's the time? And you can ask it, play my favorite music, or things like this. Little small things do indeed work. But if you want to have an actual conversation, Alexa is not the place to go. So yeah, I am worried. At the same time, I feel I've got good job security because we're not going to run out of problems. It will stay with us for a long time. And with that, I would like to invite the audience for any kind of questions that you might have.
Okay, thank you very much, Christoph, for this amazing talk. I think this talk is a little bit skeptic, but this is what we actually want to have here in our meetings. Because every time we are talking about some positive and negative sides of technology, in this case, you have presented the dark side of the, let's say, development of social robotics. So a little bit maybe sad presentation, but the whole presentation told us that maybe robots are over promoted. Maybe companies buying robots only for promotional purposes. So I think this is definitely a perfect introduction to our upcoming panel. But also, I think this presentation was very complementary to this first one. But of course, we have a couple of minutes to answer questions regarding your presentation. So we see on the chat some. Maybe you can choose which one you would like to answer. So you can choose. We have some comments also, but also interesting questions. The last one is very long, but yeah.
So yeah, there's a point here. Robots are expensive to produce today. Yeah, so this is something that I came across around as well. And that is that surprisingly, a lot of things, when you scale them up, they become cheaper. And computing power has become so cheap in comparison. I mean, it's fantastic. So yeah, but for robots, strangely enough, that hasn't worked. So robots hasn't become cheaper, not in the way that phones have or things like this. And I was told that the main reason for that are the motors. Producing good motors is just expensive, and we haven't seen the economy of scale happen to motors as we have to many other things. So that is something indeed that is a problem, could be a potential explanation is. Then we got the question about virtual reality. Is that a way out? Well, in a way it already is. I mean, the time that our kids spend with phones is scary. But then again, of course, the argument is like they don't actually spend time with phone, but they actually spend time talking to other people and their friends. And so it's actually interaction, human-human interaction, and not human-robot interaction or human-agent interaction. So that's probably something else. He's next to the Cyclone and K9. Oh, somebody find Wally. Oh, thank you. That's great. Oh, that's really good. I'll have a look at that. Next to Cyclone and K9. Okay. Oh, yeah. Future cars, autonomous vehicles. Oh, yeah, that's a really good one. And actually, we're working on that right now. So I always thought that, maybe the whole ethical aspects of robotics will kind of like come to an eruption, volcanic eruptions because of, let's say, autonomous killing machines. So that people would become upset about that. But all those killer drones that do this right now does not really seem to bother so many people because they're not really being used en masse. So indeed, the ethics around autonomous vehicles becomes really, really important. There's actually potentially, this could be the first successful social, well, it's not a social robot, it is a robot, certainly. And we also have interesting interactions with cars, I suppose. And it has, this is an actual robot that can hurt you, right? You can die in this robot, right? So things become very interesting, particularly around the issue that cars and computers, for that matter, don't have any moral intuition. Like when we are in a car and we drive down the road and something happens, we act. We don't think, we just do. And this is our excuse for incompetence. But robots and cars don't have this luxury of a moral intuition. Everything has to be calculated. There's no way around it. They can only act by calculating. And so you have to define upfront what is acceptable social or moral behavior. It forces us to formalize what is right and what is wrong before we actually start driving. And even, let's say, if you can't make a decision, well, you roll, and then you just roll a dice, maybe. That's then the only other option that an autonomous vehicle has is just random behavior. Right now it gets particularly interesting because they don't work perfectly, and this is a real issue. So the problem is the following: if the car would stop every time that something goes on that it cannot explain or doesn't know what's happening, I mean, the safe thing would be if you encounter a situation, something goes wrong, you don't know what's going on, stop. It seems like a very safe approach. Problem is, the car would never go anywhere. You would be stopping all the time. It just wouldn't work. So you have to put in a certain threshold where you say, okay, if something weird happens, I accept it. And if it's still there 1 or 2 seconds later, then I'll take it seriously, but I'll ignore it for now and just hope that it goes away. So engineers have to put in this threshold to make the car go anywhere at all. And then the question is, what is an acceptable threshold? How long is it okay to ignore something? And again, we just last year or the year before, the Uber crash, we had the first death. I mean, not the driver, but a bystander essentially was killed by an autonomous vehicle, and this kind of triggers off all these questions about now, well, what is acceptable, what is not? And what we know already right now is that the interaction we have right now doesn't work, because legally you're obliged to have your hands on the wheels and pay attention to the traffic while you're in an autonomous mode. People don't do that. People don't do that. What they do is that they actually watch movies on their phones. They recently, even 2 guys have been caught sleeping in their cars while being on autopilot. So the idea that you can make people sit and pay attention is just not going to happen. So we'll really have to look into how we design this human-robot interaction. Definitely a good one. Yeah, okay, so that was a couple of questions. Maybe we should switch over to the panel. You're still muted.
Okay, sorry. Of course, this is definitely time for our panel. So let me briefly introduce our panelists. I would like to share my screen. So we are already familiar with our speakers. So it's time to present our panelists. So we have, as you can see, 5 persons in our panel. I will be moderator of this panel, and the goal of this panel is to discuss these issues that you mentioned, Christoph, but also Agnieszka Wykowska. Let's start with Paweł Zarzycki, but I need to underline that I would like to just present some elements of this big biography. So Paweł Zarzycki is a founder of Smart Robotics. He graduated from the Warsaw University of Technology in Computer Engineering, also MBA from Oxford Brookes University. Paweł is an expert in the field of artificial intelligence and social robotics. He was named one of the 50 most creative business people in Poland in 2015, and was the finalist in the Singularity EU Global Impact Challenge 2018. He published articles on semantic technologies and controlled natural languages. He's currently a doctoral candidate and, of course, member of the HumanTech Center. Next person, Mateusz Łukasiak, is a graduate of the Medical University of Warsaw and president of the Polish Transhumanist Association and organizer of the annual scientific conferences on transhumanist ideas, strategies, doubts. He is interested in application of new technologies in medicine and human-machine interaction, in particular longevity and morphological freedom realized also through cyborgization. Kamil Muzyka is a doctoral candidate at the Institute of Law Studies of the Polish Academy of Sciences. He specialized in the space production law and artificial intelligence law. He published numerous articles on the legal aspect of AI. He is a member of the Polish Transhumanist Association and many scientific organizations you can see and read on the screen. He completed a fellowship at the Institute for Ethics and Emerging Technologies at Trinity College in Hartford. He focuses on robotization of industry, self-replicating technologies, and legal aspects of synthetic biology and industrial astrobiology. So, as you can see, we have very interesting guests, very interesting members of our panel with different background, different specialization. So I would like to start with such question. Because we are talking about, as I said, dark sides of interaction with robots, as Christoph mentioned about, for example, kids' interaction with robots, right? And of course, we know that it's the best choice is always to talk with people, but sometimes, of course, it's impossible or very hard to find somebody to talk with. But my question is about the using natural language in communication with robots. Is it an anthropomorphic trap for humans? Because we are designing robots in order to make communication with them comfortable for us, for our own convenience. So this is my question, especially that we are going to have in January, our guest will be Guy Hoffman. He is a robot designer, and also he's very interested in such topic. We had today, during first part of our event, among our entities, Guy, but I think now he's already gone. So I would like to repeat my question about the using natural language in communication. Is it kind of trap for humans to design robots with such possibility to talk by using natural language? This is my question for all the panelists.
Well, if I can start, the answer to this question, well, the problem is that what do we mean by natural language is that it is the language that we actually use by repetition. We use in everyday interaction with other humans. And this is what even Isaac Asimov found in creating the robot stories with the laws of robotics, where the robots actually interpreted their commands and their laws in a different manner. Of course, we also see this in the fields like ethno-electronics and other approaches to ethnicity or even racial studies with the use of artificial intelligence, where we see how the language bias actually can create data and even enforce or even reinforce bias towards different groups. So in this case, well, we would have a problem that a robot would actually be a tool for enforcing, for example, racism, homophobia, xenophobia, but it's just a tool. It doesn't understand that these words mean different things, because the language has been the language has been shaped by culture, by history and interaction and art. That's from my perspective how I see it.
Camille, can I ask you a question?
Of course.
Yeah, of course. Feel free.
Do you know any robot that has a brown skin color?
Yeah, Bina 48. I even have a picture with her from Hanson Robotics. Well, It's
Okay,
a
that's one. That's one.
brown cover. Okay, but well, it's not a real human skin.
Exactly. But
Okay, point taken. But the point is here that if you look at robots, almost all of them are made with white plastic, and there's nothing even to do with language or anything. And this is actually something that the developers of the robots decided for. Give them white skin, right? So I think we have to blame ourselves for that one.
Sure.
And we need to mention that Bina 48 is a copy of a real person. So it's not, robots, social robots for market. So the story behind it is completely, different. So I think it's not appropriate example. So who wants to answer to this question about natural language in communication with the robots?
Może ja pozwolę sobie dorzucić 2 słowa. Będę mówił po polsku. Mam nadzieję, że tłumaczenie w czasie rzeczywistym będzie dla naszych pozostałych prelegentów dostępne.
Yeah, I guess I think it's possible to translate your speech in real time, so feel free. Go ahead.
Wydaje mi się, że jeżeli mówimy o wchodzeniu w interakcję z robotami, to mimo wszystko głównym konsumentem tych interakcji jednak jest człowiek, więc chyba naturalnym będzie oczekiwanie, że będziemy wchodzili w te interakcje, czy będziemy chcieli wchodzić w te interakcje przy pomocy interfejsu, który jest dla człowieka najwygodniejszy i najbardziej naturalny, a więc właśnie języka, mimiki czy gestykulacji. Oczywiście, tak jak wspominał i Chris i Agnieszka, Christoph, przepraszam, i Agnieszka, bardzo dużo w tej chwili, bardzo daleka jeszcze droga do tego, żeby ta interakcja, o ile kiedykolwiek osiągnęła poziom komunikacji z człowiekiem, ale wydaje się, że na przykład rozwój wirtualnych asystentów, takich jak Siri, Cortana czy googlowski asystent, jednak daje nadzieję na to, że może chociaż ta werbalna interakcja będzie niedługo pozwalała na w miarę naturalne wchodzenie w interakcję jakąś z maszynami. Pamiętajmy, że do niedawna jeszcze całkowicie w nienaturalny dla człowieka sposób wchodziliśmy w interakcję z maszynami poprzez wstukiwanie wyłącznie komend przez klawiaturę. W tej chwili może trochę bardziej naturalnie dla człowieka przez wskazywanie na interfejsach dotykowych.
Okay, thank you, Mateusz, for your insight. Any other comments or opinions regarding this topic? If not, so I have one another.
Well, I guess you could already guess that from my perspective.
Yeah.
Yes, it is a trap. Clearly.
Okay.
And
Okay.
Very simple, because as soon as you use speech, you raise the expectations to a level of what other humans can do, and getting people down from that to what it actually can do is always a disillusionment, disappointment. You might end up with a functionality that's still useful. I mean, maybe the Amazon Alexa or Google Dot are still a little bit useful. Okay, sure. But again, if you give the robots even then a human shape, and even again set the expectation high, you're setting yourself up to failure. So something like the iBot dog is actually much closer to, or much better at managing expectations of what you can really do. So yeah, I mean, again, there is progress. Obviously, we made progress in speech recognition, but try and take a robot, put it into a shopping mall or a train station and let it operate there. It's not going to work. The reason why Pepper has got a touch display is because if you put Pepper into a public place, speech recognition fails miserably. So you have to resort going back to touch screen and entering your information this way because recognition just doesn't work. It can easily speak. I mean, it can just use speakers to do text-to-speech. That is easy, but the recognition and understanding of speech, it's really, really hard thing to do.
Thank you so much. Next question I would like to address especially to Agnieszka Wykowska, because when I listen to your research, it comes to my mind such a question. Does research on robot interaction make generally sense? Because after all, we may observe similar behavior as in the case of the interaction with people. So the same or very similar effect then we can observe in a social relation. I'm talking about, for example, gaze that you presented during your presentation, the gaze contacts, for example, or social influence. So I wonder, what do you think about it? Because sometimes I see that the psychological effects are completely the same. Group pressure, for example. Because we anthropomorphize robots, so because of this process of anthropomorphization, we see something similar. What's your opinion about it?
Thanks for the question. It's a very important one, and of course, I'm biased, so the answer will be in that direction. And of course, my answer is yes. Of course, it makes sense to do this kind of research. I guess the question is what question you're asking. So what I was trying to convey in my presentation is that robots can be used as tools for understanding the human social, or in general, cognition, not necessarily only social. The huge benefit of using robots in that way, as compared to years of decades of using just schematic faces on the screen, is that we actually learn something about a more ecologically valid situation. Now, of course, this is still just a robot, so the best would be to have a human-human interaction. But there you lose experimental control. So I don't know if you remember this one picture that I showed you when we did the sense of agency experiment, and we had to have the human completely covered because we knew that we won't be able to control her micro expressions on her face, because you can't do that with a human. I can't ask a human to make a gaze shift at exactly 500 milliseconds before the target appearance or after target appearance, doesn't matter. I cannot make a person to do that over 200 trials with exactly the same timing and without using any other facial expressions. Yeah. So in terms of very fundamental research, where you try to address questions about how the human cognition works, you need to have experiments that are with many repetitions for running statistics later on that. Many repetitions of the very same behavior with extremely controlled environment. And that is something that has been, let's say, implemented in the lab in the past, as I say, with schematic faces on the screen. But now we have this opportunity that we can actually have an interaction, so we can bring it closer to ecological validity. So in that sense, it's extremely useful for fundamental research in cognitive neuroscience. Now, another application in terms of scientific, let's say, endeavor is computational modeling. I mean, from what I know from roboticists is that most of the computational models that are beautifully running on their computers, the moment you implement them on an embodied robot, things don't work anymore. So you take any attentional, computational model and you try to actually make it work on a robot that moves, that its head moves, its environment moves all the time because of the head and of the eyes and so on and so forth. That's a huge challenge. So again, by having a possibility of embodiment for computational models, again, we can learn something about our cognition and where there are challenges and where there are gaps of understanding of, for example, how an attentional system works in a human. So when you ask me about whether research on robots makes sense, I say absolutely yes, because they are tools for, this is how we use them, for understanding humans. Now, if you ask a question of whether it makes sense to compare, let's say, human behavior and human-human interaction and to human-robot interaction, again, I think it does. The fact that you referred to some studies where people show that, yes, you observe similar mechanisms, that's actually great, but that's an empirical question that needs to be answered because we don't know. So I don't know if a mutual gaze with a robot will evoke a similar mechanism as it invokes in a human-human interaction. Now, why do I need to know that? Well, maybe if I want to design a robot for that induces engagement in an elderly person, and that actually I manage by this engagement to convince the person to take medication at the right time and be systematic with that, because the robot will be engaging for the person, maybe it's worth a try, right? So I think these are all very important empirical questions, but that's why we need to make this research to be able to answer these questions. I hope I answered your question.
Yeah, perfect. Thank you so much. So to summarize your answer, robot is a perfect tool. We can replace a real subject, real person, and use a robot, and then because the processes are sometimes very similar. Behavior are very similar. Interaction with robots is like interaction with the real person sometimes. That's why we can say that sometimes we can replace, we can extrapolate our effects. So for researcher, of course, it's a very useful tool. But now I would like to move to another question about robots in education, right? Because we are talking now a lot about some negative aspects of robots. We are talking about that is kind of trap, but let's move to something positive, right? Because we have some evidences that robots can help in education. So what do you think about Pavel? You are designer of robots, so I wonder what you think about. Oh, you are muted, I guess. We can't hear you. Something is wrong with the, oh, now maybe. Oh, something is wrong. So maybe you have to change something with your settings, right? Because we can't hear you. Oh, still the same story.
You can hear me now?
Oh, now it's okay. Perfect.
Oh, sorry for this, I think. Yeah, well, thanks a lot for the invitation, and I really admired both presentations. And I'm in this here on this event have this practitionist point of view, and of course I know all of the failed somehow projects that Christoph shown, and even when I was explaining social robotics aspects to students sometime recently, I showed them the Jibo. It's one of the example of amazing expectations and something that hasn't been delivered. But in the same time, I'm a person who believes and keeps trying to build this kind of solution. And replying to maybe your previous question about the importance of research in human-robot interaction, and this kind of experiments, results, these studies help us to better understand and kind of formulates something like a guidance how to build better robots, and all of this information how this interaction happens is really significant piece of information for people like me and my team, how to try to build these robots. And definitely, I agree with the statement that we're pretty far from the bringing to the market real value. If you compare the sophistication of the robot in comparison to what's the penetration of the market, the most sold devices are vacuum cleaners. And I think the next category of social robots that had some market success were mainly for entertainment, and one another application is education, as you mentioned. As far as I know, there are several studies showing that really robots make a difference in education, and especially if we compare them to either inanimated objects or agents, artificial agents that are purely virtual, for example, only in computers. And when we combine it with personalization, using, for example, some artificial intelligence models like reinforcement learning, so the robot can adapt to what's happening with the kid that the robot is tutoring, or the extra interaction, taking into consideration the affective state of the kid, what's the emotional response. This all of the things that we saw in the first presentation about gazing and having shared attention, etc. It really helps to improve the educational outcome.
Thank you, Paweł. Any other comments from our panelists? Christoph.
Yeah, I mean, we're just in the process of publishing a book which is called Robots in Education, which essentially talks exactly about that. And again, we kind of have to be, unfortunately, a bit realistic, and certain things work and certain things don't work. So the idea that you would have a robot managing a classroom by itself, it's not going to happen, right? You cannot replace a teacher with a robot. It's no way even close. It's just, it's not going to happen anywhere close. At the same time, the interactive material based on a computer, on tablets, the interactivity that kids have these days with learning things on a computational device, that's getting really good. And the question is, between this learning technology becoming more and more interactive, and they can talk to it and they can do all sorts of things, why would you even want to bother with a robot when you can just give them a tablet and that will be so much better, or definitely more cost effective? And so I guess one of the answers can only be is that only the combination of a teacher with a robot and students has a chance of success if they are working together. So in that sense, again, we're again in the situation where we're having a solution looking for a problem. Like, oh, we got robots, so what are we going to do with them? Oh, blah, blah, let's do education, because that's kind of the topics that people get funding for. Same thing with elderly care. You get funding from that, because these are societal problems that politicians have identified, and if you can claim that you make some contribution in this area, you get a chance of success, because you will always have to justify your research in terms of the societal impact and how it's going to improve the lives of people. But of course, we all deep down in our heart know that that's not going to happen anytime soon. So yes, we can definitely spend time and effort into doing this, but in particular in the field of education, let's be realistic. We're competing with interactive media. That is much, much easier. And we got iPads, and this is really going strong. And you can never be as good as a human teacher. So at best, you can be a companion to the teacher. And this is probably as good as it gets right now.
Thank you. So maybe instead of building robots, we have to focus on building positive, good, let's say, cooperative relations with teachers, with colleagues in the school. But I would like to continue this topic because during first presentation, we had two types of robot: humanoid robot and machine-like robots. Sometimes developers are trying to develop social robots similar to the person, to a real person, sometimes human-like. What do you think about the children's mental development, consequences of building human-like or machine-like robots? Do you know any studies about it? Is it something positive to make some robots to produce robots machine-like, or compared to human-like robots?
Well, I recall one study by Kate Darling, which was the study was using the dinosaur robot, which was used in order to research whether the kids would actually harm a toy that can make sounds, is like plushy and so on, and they were told to play with it, pet the toy, but afterwards they were ordered to actually pull its legs or pull its tail, and it was screaming, and those kids, most of them, refused to actually do harm to this robot. So that is one study I actually recall by Kate Darling, although I don't know any further studies, but I suppose there were, about using, for example, other non-human but animal-like robots, or even human-like robots in the classroom and in development. Especially, I would even suggest somebody compare the therapeutical aspect of robots, for example, with hypotherapy, dogotherapy, and so on, with substituting the live robots, the living organisms with robots. I have an anecdote I can actually share. When I was in 2015 at Tsukuba Robot Show, my friend Joanna actually held the seal that Christoph was talking about, this furry little seal that was purring and so on. And she was very happy holding on her hand and said, "Oh, it is sweet." But afterwards she was like stricken with a shock when she actually realized, wait, that's a robot. That's not an animal. And many actually science fiction authors even approached the idea. For example, Frederick Pohl in Gateway, or Xia Jia in the Tong Tong Summer, and one another short story from Clark's World, where there were actually synthetic animals, not like from the original Blade Runner, but those actually synthetic animals used for therapy for people with depression.
Exactly. I think the best example is Paro robot, but Christoph already mentioned about this kind of robot. Any other insights, opinions, comments?
I think what I could add here is we at least people working with social robotics know about the phenomenon called uncanny valley, and the robots that are quite close, and there are several projects out there in the world that are trying to build a robot that is very, very similar to a human being, but what they are achieving is rather awkwardness. And from the other hand, robots that don't really have a shape of a human, and we can learn from the film industry. For example, WALL-E that has been mentioned today doesn't look like a human being, but have certain attributes of interaction among the other, gaze and mimic and expressiveness, and expressing its internal emotions, which makes it a very likable creature. So maybe that's what's working even better.
Okay, I'm sorry if the uncanny valley comes up. I have to give my 2 cents for that, because I strongly disagree with that uncanny valley theory, because it's not a valley, it's a cliff. So yes, when robots become more human-like, animal-like and cute, people start to like it more. And at some point, they don't like them anymore. Okay, we know that. So it goes up and then you fall down. We know that. But we have never actually seen robots actually picking up again on the right side where, it would become indistinguishable from humans. It's not a valley, it's a cliff, and you just die. And the thing is that this theory has been used and abused by so many robotic developers to put the blame away from the robot to the people. They say like, oh, there's something going on, something's wrong with the humans. They got this thing, uncanny valley, and yeah, that's their problem. There's nothing to do with my robot. And in a way, it's true, but still it doesn't take away their responsibility. What happens is like the more human-like you make something, people are trained to see other people. And if there's something wrong with them, we immediately detect it. So I limp, right? And people constantly come up to me and say, hey, what's wrong with your leg? And I say like, oh yeah, well, I limp, it's just me. People see it immediately. If somebody limps, it pops into your mind and you see, wow, something is wrong with this person. So we are so good at looking at other people that the complexity just explodes. It becomes so much more difficult because there are 1,000 more ways of how you can fail. So it is just the complexity of the problem that leads to a failure in the sense that it just doesn't look any good anymore because we didn't get it right. So, and recovering from that hasn't really happened, and I'm not sure it ever will. So in that sense, probably the sweet spot is still around Sony's Aibo Dark, because then you got the loveliness and the cuteness, not much expectations. So that's probably the sweet spot. And Hiroshi Shiguro's androids, yeah, they've been trying it for years, and they make progress. And Erica, in its latest iteration, it can certainly do things. And it was indeed set up to be like, let's get the best AI technology, the best communication technology. They maxed it out and they did good. But still, it is not good enough. That's the problem. So no uncanny valley, uncanny cliff.
Well, I guess, if I may, I don't know why we would be aiming for designing robots that look exactly like human and behave exactly like human. I don't see a point in that. And in addition, of course, there's an ethical aspect of that, because we should never aim, I think, ethically speaking, and for deceiving people into robots. And Christoph mentioned that in his talk, into making people believe that the robots can or are something else than they actually are. So I wouldn't see really a point in that. I think no extreme is ever good in whatever domain, and also being extreme and trying to build robots that are superhuman-like, it doesn't make probably much sense. But I think what does make sense is to endow robots with some human-like characteristics for certain applications. So I think it always has to be put in the context of an application that we want to use the robot for. So if the robot is to train joint attention for kids diagnosed with autism, it has to have eyes. There's no other, well, it can have a finger for pointing, but it has to have something that then the kid would be able to transfer that skill into a human, right? And actually our preliminary data show that that this is happening, that kids are able to get better in certain mechanisms, and then they transfer that skill into interaction with humans, because that's the most important point. Of course, we don't want to train kids being super social with robots, but not with humans. The whole ultimate idea is that to transfer those skills to humans. So in order to transfer those skills to humans, we need to have some human-like features in the robot, right? Maybe it's an empirical question also to ask. Maybe we can have induce, let's say, joint attention with other effectors in the robot, and then the kids would eventually generalize to eyes or pointing and gestures in humans. But probably a better bet is to endow robots with some similarity but I wouldn't go too far. As I say, no extreme is good, I think. And it's very important that everybody's aware that this is just a robot. It's not a human. It's not going to be a human ever. It's just a machine. It's just a tool. It's maybe a toy for if you want to talk to kids. But for certain functionality, it's good to have some human-like features, I think.
So Agnieszka, I have to ask you a question, if I may.
Okay. Sure, go ahead. Yeah.
Okay, so let's take the example that I convinced the New Zealand government to give me, I don't know, $1 billion. And I'm able to do what Hiroshi Ishiguro did, which means making a copy of a person, right? And since you are such a smart and beautiful and wonderful woman, I decide to make a copy of you. How would that make you feel?
Awful.
Okay.
But thank you. No, as I said, I
Okay.
absolutely disagree with this approach of being super extreme on human likeness. I said just some characteristics in the robot.
Okay, let's take this a bit further. Let's say I take this robot and I would take a baseball bat and wham it, right? Is that okay? How would that make you feel?
Well, I think that would be, for me, independent of whether it looks like me or not. Maybe it would have that's an interesting, there are rubber hand illusion experiments with robots, right? So maybe you embody yourself more in the robot when it looks more like you. But in general, I think these are two independent questions.
Well, most people that I ask this question go like, oh, no, And so the point here is like, we can't get away with saying robots are a tool because they're not just a tool and they represent something. They represent at least the idea of a human, even if it's not an individual copy of a person, it still resembles something like human or humankind. And the actions that you do towards it need to be seen in that context. And so, we did this experiment where people smash robot to pieces, and we gave them a hammer and we asked them to smash it, and they'd smashed robots, no problem, but it makes them uncomfortable. So in that sense, this is the thing that we are getting back to. Is like, yes, we know robots are machine, but we also know that they represent something. They represent either an animal or they represent humans. So that's a representational part to it. And also that they are not just machines. So we know that as well. And the question about, do we really need more studies to prove that point? I'd guess no. I mean, so many studies have done so many different aspects. And so I think it's pretty safe to assume that, yes, they are not just machines. I think we can settle on that. So we do not need more questions or studies to just only prove that point. I think we're done. The thing about what you say about the application area, yes, absolutely. So if you actually have to develop a robot for an application area, and you have a robot that can look, you have to program it to look around in a way that is acceptable and nice and good. And for that, you need to do studies, of course, because you have no way. You have to program it in a way, right? There's no choice.
Yeah. So regarding your point about them being perceived as more than just tools, first of all, I think this is an ethical aspect that needs to be addressed, and it's our task. It's an ethical task to actually keep reminding people that they're just a machine. But that aside, I mean, humans have this enormous tendency for anthropomorphism in general, and kids have dolls. Dolls look like humans. Kids have pet toys. So we've been doing that all along history of mankind, and I don't see robots in any way different from that. You also need to explain at some point to the kid, this is just a doll, don't cry when it gets lost, or it's not another baby, it's just, and by the way, baby dolls can become extremely realistic. So I think we've been dealing with that issue since forever, and I don't think robots are much different.
Yeah, but still, I mean, like, the extent that people go to, little anecdote, like cuddly toys, right? my kids had them, you know, the thing you give them to fall asleep, right? If that particular little like fluffy little thing gets lost, it's drama. It's real drama. So tip is, whenever you buy such a thing, buy at least 3 of them. You know, put 2 in the cupboard for when the first and the second one get lost, so you can pull out another one. Yeah.
Thank you very much for your comments. Short explanation for our attendees. We are talking about social robots, right? So it's all about social robots, not industrial robots, right? Because I hope we agree that industrial robots are very helpful currently, and lots of companies trying to, but sometimes, of course, it's very sad, but it's, you know, sometimes our workers are very tired. They do it some kind of routine activity, routine work. So for them, it's very helpful to use industrial robots. But of course, the problem that we are facing now is social robotics, right? Is it a trap, as I said before, or not? So this is related with my next question about cyborgization of society, because Elon Musk talks about it. Elon Musk talked that we have to stop to do it, and but sometimes I think such cyborgization could be maybe helpful from medical reasons. It's maybe sometimes even necessary. But my question is about the enriching people with electronic elements to increase their cognitive or motor abilities. So because even now we have some successful attempts to combine, let's say, protein and silicon. The good example is Xenobot robot, the world's first ever living robot. So my question is it a real threat or not? Should we afraid of it, of this process? So this question is, I think, especially for our guest from society, transhumanism society, I guess. So what do you think about it?
Pozwolę sobie może w takim razie zacząć dyskusję. Wydaje mi się, że generalnie skłonność do maksymalizacji, optymalizacji, poprawiania człowiekowi towarzyszy tak naprawdę od zawsze, tylko że kiedyś mogliśmy na te cechy wpływać wyłącznie poprzez dietę, ćwiczenia, praktykę, czy jakieś praktyki takie medytacyjne. Dzisiaj mamy trochę inne narzędzia, które pozwalają nam na optymalizację naszych możliwości. Możemy popatrzeć na pewną branżę, która już się rozwinęła, można powiedzieć, a mianowicie na poprawę zdolności kognitywnych czy wydolności fizycznej przy pomocy środków farmakologicznych i w jakiś sposób przełożyć to, co się tam dzieje, na to, co się być może będzie działo albo nie będzie działo w przyszłości, jeśli chodzi o łączenie w jakiś sposób organizmów żywych i elementów nieorganicznych. Wydaje mi się, że daje to pewne nadzieje. Na przykład ostatnio dość głośno było o Neuralinku Elona Muska i wydaje mi się, że on daje chociażby nadzieję, czy generalnie interfejsy typu BCI, Brain Computer Interfaces, dają nadzieję na przykład dla paraplegików, dla osób, które mają jakieś dysfunkcje narządów ruchu i być może właśnie tego typu implanty, które sterowałyby robotami, które pomagałyby im w normalnym, codziennym funkcjonowaniu, byłyby jakimś sensownym zastosowaniem tych technologii. Oczywiście wszyscy fantazjują o coraz doskonalszych protezach, czy to narządu ruchu, czy innych organów, niekoniecznie mechanicznych, może też bionicznych, które w tej chwili są na coraz wyższym poziomie i coraz bliżej realizacji. Ale wydaje mi się, że jest ryzyko, bo pamiętajmy, że każdy element nieorganiczny, każdy element nieorganiczny może zostać włączony lub wyłączony. Więc ktoś korzystający z jakiegoś elektronicznego odpowiednika swojego organu, kończyny, etc., musiałby się liczyć potencjalnie z tym, że arbitralnie może to coś przez producenta, ten element może przez producenta zostać po prostu wyłączony w pewnym momencie z jakiegoś powodu. Więc nawet kiedy już fantazjujemy i wyobrażamy sobie istnienie takich zespoleń organiczno-nieorganicznych, to wydaje mi się, że od razu w głowie rodzą się pewne problemy ciekawe natury prawnej, jak takie zespolenia miałyby działać, jakie miały być skutki występowania takich zespoleń. O tym na przykład pisze dr Kamil Mamak, który w ogóle zajmuje się między innymi prawnych problemów w nowych technologiach. Także bardzo gorąco polecam.
Well, what I can add here is that, first of all, a xenobot is not a cyborg. It's a biological automaton, something like the Shoggoth from the H.P. Lovecraft's At the Mountains of Madness, being a tentacled biological robot. And things like that, like, for example, biological robots aren't anything new because we have synthetic biology and even xenobiology, but it's not related to the xenobot because xenobot takes its name from a frog. That's the actual living frog. It was made from frog embryos. And the xenobiology is based on artificial compounds, but has similar mechanisms to DNA and RNA for replication, but only for creating, for example, synthetic bacteria or, for example, nanomotors. And also we have to recall that in this case, for example, different types of robots or even in different mediums of robotization, because we were talking about hard shell robots, and not, for example, soft robots, not biological robots, and things that can be programmed and used as tools. In my field of space manufacturing, we are frequently discussing self-replicating robots, or even robots utilizing space resources in order to create new robots, new space objects, or repair themselves, and so on, in order to maintain. But we still keep in mind that they'll have to utilize the materials that they have in their vicinity. And that is what will be their medium. For example, people are made of flesh, are made of proteins, but this is what we have in our environment. If you strip the earth from plants and bacteria, no human would even have anything to breathe or anything to eat, and they wouldn't replicate. So in the case of cyborgs, as we say, and the legal consequence of cyborgization, well, there are many things. For example, there is the liability and responsibility for any damage that can be caused by a cyberware limb, and any liability, for example, for breaching of security. So that would actually have repercussions, like people having their data stolen, data corrupted, or even their being remotely controlled in a similar way that we saw in the Repo Man. So, but anyway, there is going to be a lot of work on homologation, on creating standards for those cyberware, so it won't be as cyberpunkish as some people would like to see it in the 2020, like people doing their own cyberware in the chop shops. Maybe some will do, but most of them would have to be very secure. And for example, you can, if you can be tracked, you can be targeted, and then when you can be targeted, you can be killed. That is the first rule of naval warfare, especially submarine warfare, and it translates to cyborgs and to human safety and security in, for example, surveillance capitalism and in today data economy. Furthermore, there is going to be a lot of issues with patents, open source, and even the case of criminal liability for any damage that can be caused by a person whose cyberware got hacked. And it is going to be a quite similar to the ideas of hacking a well, remote controlled or autonomous or autonomous robot. So there are many issues that can be projected today, but there will be issues that we cannot project because, well, human ingenuity is the basis for any invention and discovery, and that's what makes it well, unpredictable for today's lawyers to actually see what the crimes involving cyberware or BCI will be in the future. We can predict something with a linear prediction, but not with a, let's say, disruptive prediction, or we can predict progress, but we cannot predict change.
Okay, thank you so much. So I'm afraid that we are going to finish, but I would like to, at the end, continue your what you said at the end about prediction, right? So my question to all the panelists about the future of social robotics. So short at the end, short comments about this topic. So my question is about the change. What will change in this field of social robotics in next 20 years? Do you have any prediction? Do you have any thoughts about it? So please, from each of the panelists, short statement at the end of our panel. No future, I guess.
Pozwolę sobie może w takim razie zacząć. Pomimo tego, iż Christoph tutaj, myślę, bardzo realistyczny sposób nakreślił problemy, przed którymi stoimy, i myślę, że jest je w stanie dużo lepiej ode mnie ocenić. Jednak z pewną nadzieją i pozytywnością wydaje mi się, że powinniśmy patrzeć na te 20 lat rozwoju potencjalnego. Mam nadzieję, że chociażby właśnie wirtualni asystenci będą szli do przodu tak, jak szli do przodu przez ostatnie lata. Być może dokonają się jakieś spektakularne rewolucje w tym zakresie. A jeżeli wirtualni asystenci pójdą do przodu, to i interakcje z robotami powinny wejść na trochę wyższy poziom. Więc może z odrobinę większą, nieuzasadnioną nadzieją.
Well, I would go, okay. Go ahead.
I would add to this that despite there are plenty of challenges and the matter is very, very difficult, but still many people are trying, and both smaller and bigger. More and more researchers are working in this field, which broadens our knowledge, and also social robotics will participate from the general technological advancements because we have better and better computers, IoT devices, more and more data available for training, and more sophisticated artificial intelligence algorithms. This whole domain is quite new, and several things that are quite common on the market, like for example, natural language agents that are quite abundant now, despite their limitations, haven't been a case even 10, maybe 15 years ago. So who knows? I hope for at least some advancement in this field.
I would go personally with modular robots that could be actually self-assembled and adjusted to the user. In the way that they would be either, well, the user would pick if they would be a part of, look like part of the furniture and be part of their surrounding, or to be a physical or manifestation of a human, bear, or any kind of creature they actually wanted to be, and change it at whim. So in order to better interact with the human and in order to better serve the human, for example, if it's an elderly person or a person with disabilities, it would be far better if the robot has the capacity to actually give help or aid, instead of just being a, let's say, a talking tablet with small, with tiny hands.
I guess it's my turn now. Well, I think it's very hard to predict what's going to happen in the future. I don't think anyone had predictions about what science will have to do in the face of COVID in 2020. Things happen, and often in a very unexpected way. I remember that I had many questions, like, where are those robots now that we need them in COVID in the hospitals? I mean, it would be so useful to have them there, but of course they're not up to the task yet. So I think what I'm also a bit more optimistic than Christoph, although I do completely agree that social robots are nowhere yet in terms of being useful or being able to really coexist with us in natural daily environment. So I would be more optimistic, and I would like to maybe finish with one important comment, is that the beauty of science is that it's very often curiosity, or it should be curiosity driven, and we should pursue that curiosity that we have towards social robots, towards human-robot interaction, and then who knows when that kind of approach will be useful for society. As I've given the example of COVID, maybe we were not ready at that point, but who knows what challenges humanity will need to face. And when science kind of continues with this curiosity-driven approach and people come up with all sorts of interesting ideas, maybe some of those ideas will be turn out to be extremely helpful for the challenges to come.
I would agree with Agnieszka that predicting the future is almost impossible. And our tasks as being a scientist is to indeed confront this unknown. If we would do any kind of activity where we would know the result already, it would be pointless. It wouldn't be science. This would then be more of application engineering, where you want this predictability. You know that if you do this, then you get that. But that's not science. Science is when you do something, you got no idea what's going to happen. And so I strongly refrain from trying to make any predictions about science. However, what we can do is a process of elimination. So if something really doesn't work, at some point we just have to face up to it and just stop doing it. And there are 2 points that I'd like to raise. One is that it doesn't really make any sense to try to automate or replace something that we actually enjoy doing. So we're lazy beings, have always been lazy, and we've replaced a lot of manual labor with machines because we don't want to do that. And that, I think, is quite justified to going down this road. And that's why industrial robots have been the first robots to be built and not social robots. We started with industrial robots. So if we want to now automate or replace, for example, human touch or human communication or closeness or sociability with a robot, it doesn't seem like a smart thing to do, because this is something that we enjoy, that we want to do, and we shouldn't automate something that we actually like to do ourselves. And the second thing would be, we need to get away from this approach of we know the solution, now let's find a problem for it. We really have to move away from it because that's really not working. And the fact that we do not know a killer app, that we do not know an application area that actually works, says something. I mean, the pressure that is put upon us to justify our research and get funding for it in terms of societal impact, what kind of return of investment are you going to give us? We can't do that. Again, that's the whole point of science. We cannot accurately predict this, how much money people are going to earn because of the research we'll do. If we knew that, it wouldn't be science.
This is a perfect summary of our panel. So, as I said, we have to finish now. I'm afraid that everyone now is tired except maybe Christoph, because Christoph, for you is the beginning of the day, so maybe you are fresh, but we are a little bit tired. So I hope that you enjoy our meeting. If someone wants to explore this topic, I really recommend all the books of Christopher Bartneck and all the, of course, also the rest of the panelists, books, podcasts, and papers, scientific papers also. I would like to thank you also our viewers. Thank you very much for being with us. Also, I would like to thank you, our amazing team, HumanTech Center team, translator, for their, as always, great work. The recording from this event will be accessible on YouTube. I guess within the next 2 weeks, you can expect a recording. Finally, I would like to invite for our next meeting, because on 10th of December, we'll have the last one in this year meeting. But as I said earlier, we are going to organize one more meeting about social robotics with Guy Hoffman. So stay tuned for the upcoming events. Follow us, please subscribe us. And I would like to present at the end, the screen with the information about our last HumanTech meetings this year. So you may find the details on our website or website of our university. So it will be about cybersecurity. So something which is very important currently. Disinformation, fakes are so important for us, and we are going to invite very interesting speakers, but the details you can find on our website. Thank you very much once again. Have a good evening. Bye-bye.
Hey, see ya.